Hi, my name is Matt. I'm a solutions architect at AWS. I actually lead the solutions architecture team for our technology partners, for our top technology partners and associated programs globally. I've been with AWS for about 4.5 years, which I think translates into 49 years in Earth years. I've been doing this for a while. I might have seen some of you in other similar big data presentations. So I'm really excited to be here today because things changed this morning. I don't know how many of you caught the keynote, but there's some announcements. I'm going to try to talk about some of the new services. My main goal here, though, today with you is really to make sense of our platform for your business case. I feel really passionately about this. We talk a lot about design patterns, about AWS services, but sometimes we kind of need to take a step back and ask ourselves the question, what business case, what problem am I actually trying to solve? What's the right tool for the job? So if you take away anything from today's presentation, I hope that it's a deeper knowledge of what big data tools you can use from our portfolio to solve your actual business cases, your actual use cases. We can't do all of it. So I'm going to give you a little vignette, try to tell you some stories, give you some real-world context. But I want to hear from you, too. So I'll hang around after the talk and happy to answer questions and try to map your business case, your context, to our services. Because we have an increasing number of services at AWS. In the big data portfolio alone, this doesn't even capture all of it, to be honest. There's a new one on there, Athena, that we announced this morning. I'll be talking a little bit more about that today. And so I think when you first come to the AWS platform and the big data set of services specifically, it could be a little bit overwhelming at the beginning because there's a lot of services and it's hard to map those immediately to the problems that you're actually trying to solve. So if we think about big data or analytics in general, I like to break it down into 3 areas. The first thing that is actually a tough problem is collecting that data, storing that data. So you need to get it into the cloud to do something with it. And that's not a trivial problem when you have petabytes and terabytes of data. You might have seen a truck drive on stage this morning. We'll get to that later. It goes a long way to solving some of that data movement and collection problems. Greengrass was another thing that was announced recently, and that allows you to essentially create IoT hubs to collect Internet of Things data on premises that you can eventually analyze. There's a number of ways you can collect data on AWS. The ones I'm going to talk about today, though, are Direct Connect, which essentially allows you to create a physical connection between your on-premises data centers or co-location facilities and AWS data centers. So you can have a lower latency and in many cases faster connection to the cloud from your data centers. AWS Snowball. So we saw Snowball Edge, and you'll see some out-of-date slides. Things change so quickly, I didn't get a chance to change all my slides. So Snowball Edge and Snowmobile came out today. Kinesis is increasingly important. As recently as 2-3 years ago when I was giving these talks, it was mostly about batch analytics. It was like, let's get the data into S3, into the cloud, and then let's process a lot of it overnight. Even as recently as 2 or 3 years ago, people using Hive on EMR, it would take a day or two sometimes to process data. Things have changed incredibly. Now people are processing data in real time, and it's become the norm. Now, again, giving this talk a year or two ago, and real-time data streaming was still something that people were finding new and hard, and there was so many frameworks. Now it's kind of something that everyone is doing. We've made it easier with Kinesis to do, and Kinesis Analytics and other tools that we'll talk about. But real-time analytics is becoming the new just analytics. When people talk about analytics, when people talk about big data, very often it's streaming out of the box. And then, of course, AWS IoT. I just briefly mentioned Greengrass. Greengrass is a wonderful way for you to build your own or to buy Greengrass-supported appliances that can aggregate and collect data on premises. Or you're just simply pushing it up to the AWS IoT service. But IoT is also an important part of the big data story now. Everything is connected. It's not just sort of computers and log files anymore. It's all sorts of data from the edge. And importantly, we need to get that data and store it somewhere. So the second part is storage. And storage is also not a trivial problem. And it's something that I think is the most compelling part of the big data story for AWS. Because on premises, if you want to build a Hadoop cluster or data warehouse, but let's start with Hadoop, you need to actually couple your storage requirements with your compute requirements. If you need 100 terabytes, you need enough servers with drives in them to equal that 100 terabytes. In AWS, you can totally decouple it. You can store as much as you want in S3 and then spin up the compute capacity on demand or query it using Athena as of this morning. So by decoupling storage and sort of taking that as a separate problem in AWS, you can reduce your costs and really make more elegant solutions that are not only cheaper, but much more powerful over time. But storage, so S3, why is S3 good? S3 is kind of ties the room together. It's the place to put your data. Increasingly, people are talking about data lakes on S3. It's a bit of a buzz term, but it actually makes a lot of sense. It's a place to put all your data so you can access it using different tools for different business problems. If I've learned anything over the years, it's that no business is the same, and therefore, the tools that you use to access that data and process them are going to be different. Different BUs need different tools. And again, the flexibility of Amazon means that you can have someone using a data warehouse over here, someone else using Lambda over here, someone else using Hadoop, and that's cool, and have all that data living centrally in S3. It's highly reliable, it's affordable, it's a great place to just stick your data. Now we're getting to the point, though, that people are collecting data for years, and they're like, man, I have 400 petabytes of data. This is, despite the extremely low cost of S3, it's my bill's starting to tick up a little bit. So Glacier is great. And now you have Glacier fast retrieval and other things coming out that make it not only cost effective, but also easier to store your data in cold storage. I work with a customer that has containers, literally big shipping containers like the one we saw this morning, just peppering their lawn, dozens of them. They're each filled with tapes. That's their cold storage. It's actually pretty hot inside those containers. That world is going away. It wasn't so long ago that enterprises all had old abandoned mines filled with tapes or drives for real. And now people are moving that kind of cold storage data into Glacier because you can use that old data as part of your big data story. And now that you can process petabytes at a time easily, often in a matter of hours, if minutes sometimes, you can make use of that old data to add to the richness of the context, to solve your business case with more data. So not all data is cold or slow. That's why we have services like DynamoDB, which is our managed NoSQL service, and then Amazon Elasticsearch service, which is a managed Elasticsearch service. So these are services to do things like full text querying with Elasticsearch or schemaless, SQL-less, NoSQL querying against a really fast, high-speed data store in DynamoDB. If you need hot data, fast data, you need to cache some data, you need to retrieve it very quickly, these are great services for that. And they're part of the big story as well. A lot of people talk about the Lambda architecture, not AWS Lambda, but the Lambda architecture. And really, that's just a fancy way of saying it's important to think of your data not just as a single thing, but to tier your data, to have some data that is hot, that you need to access right away, and some data down in cold storage that you don't always need all the time, and to put it in different services depending on how quickly you need that data, what you need to do with that data. So think of your data as a living thing, and don't be afraid to store pieces of your data in different services depending on what you need to do with it. And that's why we have multiple data storage services. And then, of course, the fun part, the analytics. So we have an increasing array of analytics services. I'm not really going to get into Amazon AI. I was just playing with Polly. Has anyone messed with Polly or Recognition? If you get bored with my talk, I strongly recommend it. Try the French-Canadian accent. It's pretty cool. But there's an increasing amount of ways to process your data to derive value. And this is what analyze is. People use a lot of buzzwords in big data, but what it's all about is deriving value from your data. Take a bunch of logs and figure out what is going on. Figure out some anomaly that you didn't even know exists, some spending trend that you can change the way you procure things for your retail website. So this is what all these services are for. And I'm going to try and put these services, most importantly, in context a little bit. When should you use Redshift? When do I think you should use Redshift? When should you use EMR? When is Athena appropriate? So this is Matt's opinion that you're going to hear today. You may have a slightly different view of this, but I'll try to give you some guidance based on what I've seen in the last 4.5 years. So where do most people start? I think most people start with a data warehouse. Actually, most people usually start with something like an Aurora. And Aurora is a wonderful big data service, actually. But there's a difference between like a relational database and something like an OLTP, a transactional database, and an OLAP database or a data warehouse. They're actually built differently to do different types of queries. And so Redshift is designed to do queries against huge amounts of data, but also data that has, for example, really, really wide tables where you don't, and where you need to, say you have a table with 30 columns, and you don't necessarily need all of the data in every column for every query, right? This is where Redshift really, really shines, because it's optimized, it's columnar data storage. So if you say, show me all Matts with blue shirts on, it'll only look at the name column and the shirt column and pull out that data very quickly because it's optimized to look down columns of data very quickly instead of rows of data like in most relational databases. So for huge, huge, huge data sets, where the data is structured, or perhaps that you already have in a data warehouse or a relational database. What I most often see is just a huge honking MySQL database on premises that people have been sort of keeping alive for years. You can put that into Redshift, and suddenly your data becomes much more accessible and ultimately cheaper. So Redshift is a great place to start if you have structured data. If the people in your business are used to using SQL to query data, so standard SQL, columnar data storage, it's optimized. It's truly an enterprise-grade data warehouse. And the cool thing about Redshift, too, is it's very affordable on the low end when you don't have much data, but you can also grow it to an incredible size. So Redshift is kind of here to stay, and you can bet that it'll evolve over time. Redshift is a great place to put your data today, to use the same tools if you're using Tableau or different BI tools or analytics tools. In almost all cases, they just work with Redshift. So it's a very low-friction way to start analyzing your big data in the cloud. Your people don't have to learn new stuff. You don't have to change your tools. You can just start using it right away. Accessible. So that's easy, right? Just start using Redshift. Well, then you're like, oh man, but I have 100 terabytes of data, and that's, I have an ADSL line. That's going to take a long time to upload. So how do I get my data into the cloud? This is actually a major problem for a lot of companies. I mean, if you notice from the keynote, and some of the services we're releasing, like Snowmobile and Snowball Edge, this is something we hear from our customers, and this is why we're coming out with these services. Moving data into the cloud is a major challenge, not just for enterprises, for anybody. So how do you get your data in there so that you can actually query it with Redshift? And this is something you should think of up front. Too often I see people spinning up infrastructure, they're like, great, we're all set, where's the data? And then they have to wait 2 weeks because they forgot about that part. So there's a lot of ways you can upload your data, and in fact, I talked to a lot of people, what should I use to upload my data? Honestly, most of the time, the answer is the command line interface, the AWS command line interface. It does like multi-threading. It has opens parallel threads to upload. It's very fast, and in almost all cases, it's going to beat much more expensive options. Now, there are times when you're transferring data across continents where latency becomes a factor. That's why we have S3 CloudFront-based accelerated transfers to S3, and there's a lot of great third-party partner tools to move data. But generally speaking, for most people, uploading using the CLI is going to be perfect. Now, if you're over that ADSL line or whatever line you're using, it's not going to always suit your needs. So this is where Snowball comes in handy. You can load up your Snowball Edge device or Snowmobile truck if you're a giant enterprise and literally ship it to us. Now, Direct Connect is another option. Direct Connect doesn't necessarily make things faster. You can essentially string up a fiber or a series of fibers between your colo facilities or your on-premises data centers and us. But it definitely makes it lower latency and in a lot of cases faster, and it's reliable. You have these private, and private is a key word here, connections between your data centers and ours. And private is key. I say that because a lot of people, for various reasons, whether it's compliance or otherwise, may not want to transfer that data over the internet to us. Or maybe they don't have enough data or a business case to use Snowmobile. So this is where Direct Connect can become great. You can effectively have a private connection between a hermetically sealed VPC and AWS with running Redshift, for example, and your data center with no internet connectivity at all, but data flowing between them. And then we have Database Migration Service, which is a great tool to actually just pick up your database on premises and move it into the cloud. So a lot of different ways. This is not all of them, but these are some of the ones I see most often. But what I see most often, honestly, though, is the command line tool. With S3, it works very well. So start there, work backwards. Get your data into Redshift, start querying. So Database Migration Service is relatively new. I think a lot of people weren't aware of it, so this is why I wanted to put it up here on the screen for you. I don't know why there's only one logo there. I think when they resize my slides, it supports multiple database engines, not just SAP. So you can use Database Migration Service to pick up a variety of on-premises databases and move them into the cloud very easily. There they are. Postgres, Oracle, MySQL, Maria, SQL Server. So it covers most use cases. Most of us have an old MySQL database or SQL Server on premises. This makes it super easy to move it into the cloud, and you can target Redshift or a variety of different locations as well. So this is an old slide now, because we had the keynote this morning, and I totally forgot that I had to update this slide. I thought they were announcing that stuff tomorrow. So you can ignore parts of this. We have Snowball Edge, which actually now supports 100 terabytes and has 40 gig connectivity. You can do up to 14 gigabits per second, I think. So you can move data very, very quickly to these devices and then drop them because they won't break when you drop them. They're highly rugged, they're designed for the military, and then ship them to AWS. And I used to make this joke a lot, and it still holds true actually. A lot of the time, like FedEx, or in this case a giant shipping container, is faster than the internet. Unless you have the luxury of multi-Google Fiber in your house or huge connectivity, chances are that Snowball and Snowmobile are going to be faster for moving a lot of big data to the cloud than just over the internet. So consider it. I think it's $300 for Snowball, if I'm not mistaken. I'm not up on the latest pricing. And it's very actually affordable way to move a ton of data into the cloud so you can get started processing. So that's great. You get your data, you start querying Redshift, it's awesome. The problem is when you do select star for a mat where shirts are blue, and you get this sort of SQL dump out of Redshift, we're trying to solve a real world business problem, and if you show that sort of raw output to your CEO or CIO or CTO, it doesn't really help anybody. It doesn't tell a story. You can do the craziest join in the world, but most people don't want to look at raw output. You need a dashboard. And so you need something like a third-party solution like Tableau, or you need any variety of, or Click, or these various BI tools that we have, or now you can use QuickSight. And QuickSight is also a relatively new service that allows you to visualize your data. And there's danger in graphs, but there's also a lot of beauty in graphs. It allows you to tell stories. And one of the things that I like most about QuickSight is that you can take these sort of snapshots of your data and string them together to create sort of data visualization stories, and they're incredibly powerful. It's very easy to use. Just go to quicksite.aws to sign up. And the cool thing about QuickSight is you can point it at a variety of different data sources and really get started in just a couple minutes. So I say this isn't about the processing, but this is actually extremely important. And often, us data nerds, we forget that visualization is extremely important to deriving value from your data. And QuickSight makes that extremely easy. Honestly, in 5 minutes, just with any data, take your logs, your logs from your billing usage, for example, of AWS. Point QuickSight to that, and you can start pulling up beautiful graphs and do data visualization in just minutes. So now we have our data into Redshift, and we can visualize it using QuickSight. That's great, right? We're done. Well, the issue is, what if your data isn't structured? I dropped that word before, structured. Redshift, when you move data into it, it has to be well structured. What that means is that, say you have CSV files, you have 10 words or 10 values in a row separated by commas. Those 10 values have to correspond to 10 columns in a Redshift database. But what if you have a bunch of different data sources and you don't have the luxury of everything being nice CSV files with 10 columns on every line? How do you actually manipulate and change that data? What if people are sending you logs from different vendors, different BUs? What if some is JSON, some is XML, some is CSV? How do you normalize that data and structure it to get it into Redshift? What if you don't need all that data? What if you only need to actually care about a subset of that data? What if you're dumping all your raw data in S3, but in Redshift or in DynamoDB or wherever you're ultimately putting that data, you don't need every column. You don't need every line. There's certain conditions. You don't want to waste money by loading a bunch of data into Redshift that you don't necessarily need for your queries, right? So it's important to not just normalize your data, but also think about what data do I need for the particular location and use case that I'm solving. So if I'm putting it into DynamoDB, if it's your hot data, maybe you just need a very small subset of it. So manipulating and changing data becomes actually another non-trivial problem. You got your data, you load up 100 terabytes of data into S3, ready to load it into Redshift. Oh man, now I have 100 terabytes of unstructured data. How am I going to possibly process that and change it such that it can live in Redshift? Well, there's a couple ways of thinking about this. These days, everyone is so hot on serverless, right? So the first thing that people say to me, I'll just use Lambda. It works, yes. You can have S3 events, for example. When you put a file into S3, it can trigger an event, which triggers a Lambda function, which does some basic ETL or transformations to that data. That works well. And for a lot of use cases, that's a great place to start. But when you're talking about hundreds of terabytes of data or complicated manipulations, or if you want to take advantage of the rich ecosystem of people who have already done this and have written libraries to do complex transformations, like Omniture logs. I don't know if any of you work with those. Famously nasty. Very, they're the old ones anyway. That really essentially translates into a really wide database table, and you don't need half the data in there. So I promise you, 100,000 people who have solved this problem before. You don't need to write a Ruby script to deal with an omniscient log. Someone already has. So in order to take advantage of this, you need a framework that can do these translations for you. So Lambda is wonderful for a lot of things, but you also have to kind of do it yourself. So just think about that before you jump headlong into building a crazy complex ETL layer using Lambda. It's wonderful for basic manipulations, for responding to events, for doing like basic anomaly detection or deciding whether a file is worthwhile or not. Perfect for all those use cases. But there are alternatives. So this is the phase, I think, when most people move into, I think, what is still considered like the newer big data world with Hadoop and all the rest of this stuff. Because you got your data into S3, you're querying it using Redshift. You might have used Lambda to do some basic manipulations, but you're starting to bump up against a bit of a ceiling. Maybe you want to use some new awesome big data framework. Maybe you want to just try new tools. Maybe you are having issues with processing a huge amount of data using Lambda at scale. So when you start asking these questions, how will this work at scale? How can I get more efficient about my data processing? How can I start exposing my developers to new big data ecosystem tools? The answer is usually EMR. The EMR is my favorite service on AWS. It's what I actually have a media and entertainment background, and 4.5 years ago when I sat down in the New York office where I'm based, I sat down beside a guy with a PhD in bioinformatics, and he said, "Oh, you're media and entertainment, right? You do transcoding clusters?" "Yeah." It's like, "Oh, Hadoop, no problems." A year later, you're a Hadoop expert. That's how it works these days. The point of that story is that EMR has a really easy learning curve when it comes to Hadoop, and it removes all the ops out of it. It used to be, when I was setting up Hadoop clusters, I did do that before 5 years ago, it was hard to actually set up and maintain the clusters, install the software, maintain the software. That was a significant percentage of your job. You don't want your big data technicians who are trained data scientists spending time maintaining clusters. That's not a great use of their time or your money. They're expensive. So this is why EMR was built. It's a managed Hadoop service. And if you don't know what Hadoop is, just think of Hadoop kind of like think of it like an operating system for big data tools. I'm sure there's some people who sort of shivered when I put it that way, but that's how I like to think about it. It's a distribution. It's sort of like an operating system where multiple applications can run on top. A lot of people conflate Hadoop with MapReduce, which was one of the original batch processing, sort of data processing engines that people did batch processing with. But MapReduce is just one application that you can run on Hadoop. And now there's tons. There's Presto and Spark and Flink, and there's something new every day. And EMR provides a way to run all those applications on Hadoop in a managed way. So it's a managed cluster service, really, where the cluster is running Hadoop, and you can do distributed processing, streaming data processing, machine learning, whatever. You can run all these different big data applications on a managed cluster, and that's what EMR is. So it's extremely flexible, and it comes with all these applications that can be installed, and when you launch a Hadoop cluster, it makes all that stuff painless. So it supports Hive, Spark, Zeppelin, which is a cool visual interface, Presto, which we'll talk about later. You can even do sort of NoSQL stuff with HBase, Phoenix, and some of the new stuff like Tez, Flink. All of these applications, if you will, run on top of this managed Hadoop cluster, and we take care of the auto scaling and everything else for you. It also does really cool things like integrate with KMS, our key management service. So if you need things like encryption at rest, it makes that very easy. And for anyone who has done encryption at rest in Hadoop before in this room, you'll know that that is not always easy. So making that easy is a good thing. And it's HIPAA eligible. So it solves that compliance issue, which is also a bit of a bugbear with big data as well. So where does it fit into the puzzle? So you get your data into S3 using the CLI or Snowmobile or Snowball Edge or whatever. The use case I see most often for EMR still is essentially data transformation. It can do a lot of other things, don't get me wrong. If there's any people from the EMR service team, don't worry. I'll talk about the other stuff too. But most people are still doing batch processing, or in some cases, streaming data processing. Data comes in, whether it's via Kinesis or into S3, you transform that data, perhaps you normalize it so that you can load it into a Redshift database. It's a great sort of general data processing thing that you can use different applications to process that data in different ways. So if you stop here, if you only get this far, this is like a very sophisticated, actually, big data application that as recently as 4 or 5 years ago was reserved for white lab coats. And now it's honestly something that you can all do in about 10 or 15 minutes. There's a presentation in a workshop like this called Building Your First Big Data Application, similar title. And I strongly actually recommend you look that up on YouTube because you can actually follow the steps and do all of this yourself in about 15, 20 minutes. But that's not it. So what about ad hoc queries? What if you don't know what the data looks like? So it's one thing to say, okay, I'm going to transform the data, but what if all this data is coming in? What if the previous guy didn't make it to work and you show up and you need to figure out what this data is so that you can write the data transformation, so that you can determine if it needs to be normalized or structured so that it can be loaded into Redshift? How do you do that? What's an efficient way to do essentially like ad hoc querying of your data? So this is where Athena comes in. Now, Athena was just announced. So there are many ways to do this. In the past, what I would have done is I would have spun up an EMR cluster, I would have installed Presto on it, and then I would have issued SQL commands against data stored in S3 on Presto on EMR. Now that is actually pretty easy, but it still requires multiple steps. And I think a lot of people, if they just want to do some basic ad hoc querying, they don't want to go through all that hassle. They don't want to spin up an EMR cluster. They don't want to have to bootstrap Presto. They don't want to have to know what Presto is. So this is what Athena is. It's kind of the next level. It moves to that next level of abstraction. It moves just a little further up the stack. Underneath the covers, it's actually running Presto. So what it allows you to do is load your data into S3 and then just essentially do exploratory analytics or ad hoc queries against your data. And it supports a variety of different file formats like JSON and Avro and ORC and Parquet. So it's a wonderful way to explore your data when you don't necessarily know what is there or when you don't necessarily know what you're going to do with it yet. And this is actually really powerful because in the past, you used to have to kind of go through several iterations and get your data into a shape and then get it structured and put it into a database. But now we're getting so much data coming in, IoT devices, logs, all over the place, that very often the data is changing all the time. And you set up your big data pipeline. It used to be you had to kind of evolve your big data pipeline every few months, but now you may have to evolve it every day. And Athena is one of these tools that makes that possible and easy. You can kind of adapt to how data changes because it doesn't matter how the data is structured. You can use SQL to query any type of unstructured data on S3, no matter how it is compressed or stored and what format it's in. So it's very powerful. It's a simple concept, but extremely powerful. So they call it serverless query processing or interactive query processing. It's one of personally, my favorite announcement at reInvent. So this is, in my picture that we've been following so far, sort of where it sits, is eventually you are going to do some heavy lifting with EMR. You're going to set up some regular jobs, maybe some batch jobs or some streaming data analytics using EMR that do that regular processing of data in S3 or coming out of Kinesis and putting it into Redshift. You're going to have sort of this pipeline. But it's also handy to have Athena there when the data is changing or when you do need to do queries that fall outside of the normal data pipeline. It's a perfect sort of addition. Instead of having to spin up a secondary EMR cluster or running Presto, whatever, it's super easy. You pay for what you use, or you pay for how much data you process. So it's also very affordable as well. The thing with Athena, though, if you look closely, is that you pay for how much data you process, right? So logic goes that you should compress that data. So even for ad hoc processing, I actually do recommend, once you kind of get going, it is a good idea to use EMR to convert the data to a columnar compressed data format, like Parquet, for example. So I'm actually often using Hive on Tez on EMR to convert and sort of pre-process my data so that I can spend less money when I do ad hoc queries with Athena. So it still allows my developers to do those interactive ad hoc queries, but they will run faster because it's against a columnar data format like ORC or Parquet, and I'll pay less money because it's compressed data sitting on S3 that Athena is querying against. So this is an optional step, but an important step to consider. You don't have to normalize your data. The data can still be raw. It'll just be compressed and in a columnar binary format, and then it'll run faster and more efficiently and cheaper with Athena. So Athena is wonderful, and having a managed service for, this is effectively running Presto that allows you to run interactive queries using SQL is amazing. But sometimes you need to do other stuff. Sometimes you want to use Spark ML. Maybe you want to use Spark SQL instead of Presto for some reason. Maybe you want to use Flink. Like I said before, think of Hadoop like a distribution, an operating system. There's a lot of applications out there, and they're changing all the time. Now, we'll build managed services as our customers ask us to, on top of some of the most powerful and popular ones, like Presto with Athena. But it doesn't cover all use cases. You all have different businesses, different use cases. So often you want to run custom code. Maybe you have some custom Spark jobs written in Java that you want to run. This is where you pull back a bit and you can run these on EMR. And this is why, what I'm trying to tell you is why we have both managed services like Athena and why we also have EMR. So EMR is appropriate when you want to sort of run a diversity of things like Hive on Tez I mentioned. And you want to run Spark on another cluster. Maybe you want to run Flink or whatever on another cluster. So having both is great. Just want to make that point that just because we have Athena doesn't mean that EMR goes away. EMR is still a very important piece of the puzzle, and it's a great tool, or sort of generic toolbox to have in your knowledge base that you can use as sort of a place to experiment with new big data frameworks that run on Hadoop as they come out. Okay, so we've been talking a lot about kind of batch stuff, though. And what about real-time data? I said earlier that real-time data is really where a lot of this is moving. So in the pictures that you've seen so far, the data has been going into S3, and then when it hits S3, either it fires off an S3 event and a Lambda function does some transformation, or you process the data using EMR. But what about if you're getting data that's coming in all the time? How do you process that data as it comes in? So that's where Kinesis comes in really handy. And Kinesis has evolved a lot over the last year. So it used to be, how I used to say this was that you can think of Kinesis kind of like a queue, a very simple, extremely cost-effective, very fast queue where you can just toss streaming data and then kind of figure out what to do with it later. It's evolved since then. Now we have things like Kinesis Firehose and we have Kinesis Analytics. So now it's more of a general purpose, real-time data streaming framework. So what Kinesis gives you is a reliable, durable, cost-effective sort of front door for your data. If you have data streaming in from mobile devices, from your web applications, from IoT devices, Kinesis is a great place to store that data first. Why? Because you can put your data in Kinesis and you can either process it in real time, but it also holds on to that data for 24 hours and can hold on to it for as much as 7 days if you want. For those of you who are familiar with Kafka, a lot of similarities between Kinesis and Kafka. It's a great place to capture that data, and then you can have multiple applications pointing at Kinesis that can do different things with that data. So for example, you have a mobile game, and as things happen in that game, those actions are pushed up to a Kinesis queue. Maybe some of those actions you want to respond to in real time. Other actions you just want to capture and archive. Other actions are maybe you don't recognize, or there's some new user behavior happening in your game that you want to capture if it's sort of a massive multiplayer game. You can satisfy all of those requirements with a single sort of Kinesis stream. You can have all your data flying into the Kinesis, and then you can have 3 applications, one for real-time data processing, one for sort of analytics against user behavior, and another one to respond to some kind of real-time game event. So it's high throughput, and it makes data capture extremely easy and cost-effective. You simply add more shards to your Kinesis stream when you need more capacity. Couldn't be easier. Now, what we've added more recently is Kinesis Firehose, because what we found is some of our customers were telling us that, hey, Kinesis is awesome, but I'm actually finding it kind of hard to get my data into Kinesis. So Firehose makes it easy to capture your data, to bundle it. You can aggregate your data, and then to push it into Kinesis stream. So you can still hit the Kinesis APIs yourself or bake that into your application with the SDK. But Kinesis Firehose is a great way to get that data not only into Kinesis, but also up into S3 after Kinesis. Because people are like, I didn't want to write a Kinesis application using KCL. That sounds hard to me. I just want my streaming data to be compressed and then dumped into S3 out of my Kinesis stream. So Kinesis Firehose does that for you. Think of it like a managed KCL or a managed Kinesis data service. So very often you want to capture that log data that's coming in real time, but you don't want every single log data as a file in S3. That would be inefficient for querying with Hadoop, and it would just be hard to manage. You'd have tons and tons and tons of files. So what Firehose can do is take all those, batch them into little megabyte bundles, for example, zip them up, and then dump them as the bundles arrive into S3. That's how most people use it. And Kinesis Analytics is new too. A lot of people are asking us, this is awesome, but I want to know in real time, I want to have the ability to run queries against my data in my Kinesis streams. So back in the day, before Kinesis Analytics, you had to spin up a cluster, get that data out of the Kinesis stream, maybe put it into S3, and then have EC2 and then run analytics using Presto or Spark SQL against the data in S3. With Kinesis Analytics, you can actually run analytics queries using SQL against your data in the stream as it arrives. So this is great to get sort of real-time insights into what is happening right now for whatever your application is doing, whether it's in-game events or retail. It's a very powerful tool. That's a lot to process, so let's actually look at it in context a little bit. So here we have some mobile clients, some web clients. That data is going into Kinesis streams. What that K is, with the box, is a KCL application. KCL is a library that you can run on EC2, and it takes care of spinning up resources, EC2 instances, scaling them up, scaling them down, and then processing the data and putting it in S3. You could also use Kinesis Firehose there, where Firehose would take care of that for you, bundle the data up, aggregate it, dump it into S3. And then you're using EMR to pull the data out of Kinesis streams, process it, compress it, and turn it into a columnar data format like ORC or Parquet. Then you can do ad hoc queries against it to figure out what this data is using Athena. Then you can process it further to structure it and normalize it so you can load it into your long-term data warehouse. So now the room is starting to come together. Now, I know there's a lot of tools on there, but it's actually, if you take a step back and you look at it, it's actually a very complex architecture that has been wildly simplified by just a few services. You have an enterprise-grade data warehouse that your developers in NoSQL that are using their BI tools can use with no changes whatsoever. That use case is satisfied. You're using EMR to normalize and structure your data so that you can use Redshift in the first place. You have Athena now, so you can do ad hoc queries and figure out what all this new data is. And you're not paying as much for Athena because you're using EMR to pre-process it and compress it and turn it into a columnar data format. Last piece, you have Kinesis, and you're capturing that real-time data, and now it's not just a batch overnight story, it's a real-time data story. And this is impressive. And this will transform your business. And I really don't mean that I mean that for real. I've seen this transform people's businesses. It's analytics, real-time analytics. If you're running any kind of mobile application, capturing those events from your users in real time to detect anomalies. Maybe there's behaviors of your application that you didn't anticipate, that you don't want your users experiencing. You can now detect those and react to them in real time. So here we have Kinesis Analytics. I just wanted to show you where it fits into the puzzle in addition to Firehose. So again, same thing, except we're pushing into Kinesis Firehose instead of Kinesis Streams. Firehose is taking care of the bundling and compression and stuff and putting it in S3. We're using Kinesis Analytics to also do kind of rule-based processing of our data as it comes in. In this case, we also have Lambda, and Lambda is actually reacting to data as it hits Kinesis streams and then sending you a text using SNS if something's up. Maybe there's some security event that you detect using Kinesis Analytics. That can actually, using Lambda, it can actually do some basic data processing. Okay, let's look at this message that came into Kinesis. Hold on a second, this is like anomalous behavior. I don't like this. Let's send me a text and let me know that something is up. So again, responding in real time. Or maybe the data is coming into Kinesis and you can use Lambda to do that transformation like we talked about earlier. So again, think about real time and responding to events and how you can connect things like Kinesis streams, S3 events, and Lambda to respond in real time. Another way to respond in real time, though, is with machine learning. And there were some very cool announcements this morning with around image recognition and poly. There's also Amazon machine learning, and it's important to remember that machine learning is a key part of the big data story. Now, this is definitely something that just recently, as a few years ago, was perceived as something reserved for the white lab coats. Oh, machine learning. Whoa! I just figured out Hadoop. Stop. Now it's really actually quite easy. Doing regression, doing basic machine learning with Amazon is not only easy, but it actually can really enhance your big data platform. So when would you use machine learning in this kind of a picture that we've been drawing so far? Well, it's one thing to say, yeah, I'll respond to that event and know if it's anomalous behavior. But how do you know if it's anomalous? Do you have all the rules magically that you have this massive Lambda function that does all of these sort of checks against your data? This is where machine learning can come in really handy. You can train a model in machine learning such that it sort of understands what normal behavior is, or well, I'll stop talking about anomalies. How about what food you want to order. So you have all these people who are using a mobile app, and maybe you sign some affiliate deal with a food delivery service. And based on the user's behavior, you can be like, hey man, this guy really needs some pizza. He's having a hard time in level 4. And like a couple of you are laughing, but that's actually a real use case. Think about it. Video gamers eat a lot of pizza. Maybe I'll make some kind of business partnership with a local pizza store. How do I know if they want pizza? Because my game has nothing to do with pizza. It's about building huts in a multiplayer world. Well, it turns out that certain types of players that have certain behaviors get hungry at 4 a.m. They live in a certain part of the country. It's dinner time. You can correlate all these events. You can learn, and you don't necessarily have to have every combination. Like, if you didn't have machine learning, you would have to know every single combination that resulted in a pizza crave. With machine learning, you can train a model and infer from a certain set of parameters that this person may want pizza. So I know that sounds like kind of a silly example, but think about your own business. And think about how you could respond in real-time streaming events that are captured in Kinesis and make recommendations and tie that into other businesses. Again, augmenting your big data platform using machine learning. We work with a lot of advertisers. This is another thing too. Advertising, well, Amazon.com being one of them. And advertising, one of those things where machine learning is incredibly powerful. Not just advertising, though. What about security? Let's get back to anomalies for a second. You don't know what bad is necessarily, but you do know what is normal. And maybe you know what a set of conditions are that are different, so you can train a model against logs, for example, log data, of what things should look like versus what they should not. And when you sort of drift into that not area, you can trigger events and either auto-remediate using Lambda or send your CISO a text using SNS. So plugging machine learning into the big data story is not only easier than you think, but can be really, really beneficial. You can get started and train a model and plug it into your big data architecture, honestly, in 15 or 30 minutes if you take some of the labs. So this is fancy. You build this awesome architecture and you bring it to your boss, and they're like, okay, this is awesome, except compliance. And so, Andy Jassy was talking about this earlier today, sort of the enterprise story and how it's evolved over the years. Certainly in the four plus years that I've been at Amazon, it's evolved. But security is always super important at Amazon, and dealing with compliance and encryption is something that, quite frankly, when you're dealing with architectures and data at scale, can be hard. But we've made it a lot easier recently, certainly with KMS integration into services. So, for example, if you're using data stored in S3, or data stored in Redshift, or data stored in EMR, all of those are integrated with our key management service, our KMS service. So you can have a fully managed key solution. Now, why do you need a managed key solution? Well, because the answer is, in big data, I'll give you a real example from my life. I was working with a hospital group on the East Coast, and this hospital group had a requirement that for every patient, you had to have a unique key for encrypting that patient's data, and that key had to be rotated every day. Now, this is a big hospital group, so their key problem became a big data problem. And their infrastructure to support the keys and key rotation, even rotating the keys was like a massive job that cost them money because it was a ton of compute. So by having a managed service like KMS, they could offload. They weren't making money off key management. They're making money off healthcare. So they could offload all of that key management to KMS. So you could have very sophisticated key rotation and encryption sort of frameworks or rather workflows, and connect them very easily to multiple places where you store your data, like Redshift and EMR and S3. So everything kind of gets harder with big data because it's so big. You have hundreds of terabytes, petabytes of data, and key management and encryption is one of those things that most of us anyway are not making money off. So that's at rest. What about in transit? Well, our APIs, you can communicate with them using HTTPS and TLS encryption at rest. But what about network isolation? This is something that is relatively new, I guess, with EMR, but you can run EMR Redshift inside of VPC. And this is significant because remember we talked about Direct Connect before? And if you look at the corporate data center icon in the corner, a lot of people's fear of the cloud comes from the fact that they don't own the pipe between them and the cloud. It's the wild, crazy internet. And a lot of people talk about public cloud and private cloud. Well, I actually hate that term because you can have a private cloud with AWS if you have a direct connect from our data centers to your colo to where you're running, and you can have no public connectivity whatsoever. You can have all private addresses running EMR clusters in VPC connected to your data center or colocation facility over Direct Connect, fully encrypted using keys that you control with key rotation using KMS. That is a very sophisticated, private, secure experience for big data, and something that, quite frankly, is really hard to do on your own. I've actually had multiple customers show me their secure corner of their data center, and it's like this, literally a cage with like a chain lock fence. You can do better than that. We can all do better than that. Security is a key part of your big data story, especially once we get into compliance. A lot of you maybe working in e-commerce, working with PII and PHI. So thinking about this upfront is important. What is your security story? Do you want to be sort of public-facing, or do you want private? And the good news is you can be flexible with AWS. You can do both. Okay, so I've been up here waving my hands and stuff, but who is actually doing this? I think this is important. How can this is not a hobby. We actually have customers. A lot of people are doing this today. So let's talk about a couple of them. Redfin. So let me just build this slide out for you. Look familiar? So Redfin has this hot homes product, and they do user profile recommendations. They look for similar homes. They do essentially a mix of real-time and batch analytics to tell you, hey, you looked at this home, you should check this one out. I don't actually know if they're integrating, if they're doing kind of machine learning with EMR, but this would be a great use case for machine learning. Based on all these parameters, you were looking at these homes on a Tuesday, you live in Dallas, you're going to love this home. So that's a good use case, perhaps, for what we were talking about earlier. They use S3 as their data lake. They essentially aggregate and store all of their data in S3, and then they talk to that data using multiple services. They load it into Redshift, they transform it, and perhaps do machine learning or whatever using EMR against that data in S3. They also use DynamoDB. They have hot data that fronts or backs their website as well. You're not going to plug your website onto an enterprise data warehouse. You need a data service that has much lower latency for queries, so you can have a snappy mobile and web app. So Dynamo is perfect for that. But the takeaway here is that they're using Kinesis to take in the inbound data, they're persisting it in S3, and they're using multiple tools for different use cases to actually make sense and value out of that data. Nordstrom. I talked a little bit about retail and e-commerce. So personalized recommendations is not just a nice to have in e-commerce anymore, it's a requirement. So I don't know what stage of your life you're at, but I just got out of the Amazon recommended me diapers phase, and now I'm into Amazon recommended me Paw Patrol. So, but it needs to know a lot about me to make those recommendations accurately. It's actually processing a lot of data for a lot of customers. And Nordstrom does the same thing. They're doing personalized recommendations. And what's interesting about this is they used to have to do like micro batch jobs. Every 15, 20 minutes, they take a chunk of data, process it, then give you recommendations. But that's not good enough. Often you only have someone's attention for like a few seconds. And you need to make very quick decisions about what content to serve them or what ad to show them. These types of decisions have to be fast. So that's where the real-time streaming data piece comes in. So Lambda, Kinesis, DynamoDB, that they're making personalized recommendations using a very similar architecture that we saw. And doing analytics. I don't think that's actually QuickSight. FINRA. So we've talked about commerce, but what about the enterprise story? What's interesting about the FINRA use case is that everything in this picture here is encrypted both in transit and at rest. So I think it's a great real-world example of how you can have a compliant financial services big data story on AWS. So it's a bit messy, this slide, but they're using multiple EMR clusters running different types of applications on Hadoop. They have Postgres clusters, they have MySQL databases, a lot of stuff going on here. But what's important is that they're satisfying different requirements of different BUs, different use cases, using different tools. And ultimately, their source of truth, their data lake, if you will, it remains S3. So again, that story where you persist your data on S3, and you have different clusters, different tools that kind of orbit around it to solve different problems for different parts of your business in a secure way. So my challenge to all of you today is, I want to see your picture up here. Next time I do this talk, I want someone from this audience, I want it to be yours. It's easy to do. It's way easier than it was just even as recently as a few years ago. And hopefully your takeaway from today was that you have a slightly better understanding of where some of these tools can fit into solving your business problems. And again, I'll hang around after. I'm happy to talk in more detail about your individual problems, but thank you for your time.